All right, let's get down. All right, we're looking at vertices and the direction of a hyperbola. When it says direction, it's talking about if it's a hori or if it's a verti. Okay, is it vertical or is it horizontal?
Vertical.
All right, and then so that's what direction is. The vertices, that's where the parabolas come off of it. Okay, so let's look at the graph here. Oh, look, it's a really simple equation. Why is it simple? It's simple because usually, you see, they put the y first. Usually there's an h. Okay, and that's only if it's shifted. Okay, then this would be the a squared. The a squared is always on the positive fraction. And then you have minus, and then this would be x. Nope, I did something wrong. Does anybody know what I did wrong?
K.
Yeah, I didn't say k, I said h. Doofus. The k is always on the y, okay? The h is never on the y. And then this is the b squared. I was wondering, I thought I was crazy there, Mr. Patey. Now, what matters? What matters in terms of direction? Whichever fraction is positive, okay? As soon as one of the fractions is negative, and usually the negative fraction is second, because we like seeing that better than seeing the negative fraction in front. We know which way this goes, okay? So because the y is positive, this is a vertical, it's a vertical, not a hori. It's a vertical hyperbola. So that means it opens up and down, which means this guy is definitely not it, and this guy is definitely not it. All right, so now we have a 50% chance of getting it right, but I don't like playing odds like that, so let's get a little bit more specific. There's no h, there's no k. That means the origin is your center for both of them. There's no h, there's no k. So you just see the y squared and the x squared. Okay, so what the heck is this 9, and what the heck is this foe?
A and B.
Yeah, that's your a and your b. The a squared is 9, and the b squared is 4. Now, honestly, it doesn't really matter what the a squared and what the b squared is, and that's because the formula to find the focus point adds the a squared and the b squared. So because it adds it, it doesn't matter which one's first, which one's second. So that doesn't matter. But what does matter is that we know the a. Why? Why the a? Because we're looking for vertices, right? We don't even need to know the co-vertices, which actually don't exist for hyperbolas. I just like to say they exist because they help us find the asymptotes. But this problem doesn't even care about the asymptotes. It just goes, all right, if you know how to find the vertices and you know how to find the direction, then you should be able to answer this question. So what is my a? Nope. 3, yeah. And the a tells you how far the vertice is from the center. Okay, so let's see here. This one is 1, 2, and this one is 1, 2, 3. All right, so do we know the answer? Yeah, it's this one. All right, it's A. And actually, I guess we could say A is plus or minus 3, but it doesn't really matter because it's just a distance. It's a distance, and usually distances aren't negative. If you say a distance is negative, that just tells you the direction that you count. But that's how you would answer this guy.